Blind Beggar is a 3D audio-only game created in the scope of my master's studies at the University of Applied Sciences in St. Pölten. It is my third major project as a master's student and consists of a software component, an algorithm written in MAX MSP, and a hardware component, an Arduino board processing data from a light resistor sensor and an accelerometer/gyroscope. Let me add here that all the used components, regarding software as well as hardware, are listed in the comment section. The game is set in a medieval marketplace, and the task of the player is to gather 100 points in the role of a blind beggar. The player is sitting on a chair with covered eyes and is provided with a small basket. This basket is equipped with the before mentioned sensors, which are connected to the Arduino. Depending on which character passes by, the player has to either lift or hide the basket in order to either increase or decrease the score. The Arduino board runs on a code based on the MPU 6050 light library by Roman J.L. Fettig and Takuto Sato. This code, however, was additionally adapted by myself in order to get the right information from the light resistor sensor. The raw sensor data is then sent into MAX MSP via a serial port. The incoming raw data is firstly encoded, routed and visualized. In the following step, the data is interpreted by a support vector machine and the predicted motion is finally sent into the main gaming algorithm patch using OSC. In the main patch, the first parameter which has to be set is the type of decoding. This depends on if the audio is played back on headphones or speakers. Originally, the game was meant to be played inside a speaker array arranged in the form of a sphere. But since there's a pandemic going on, forcing us all to stay home, I also integrated a binaural decoding option. The next step is to hit that big Start Game button, which will activate the digital to analog converter and start the game. The arrangement of the audio is based on two layers, ambience and characters. The ambience consists of two kinds of sound sources, constant ambient sound and concrete sound objects. The audibility of the former depends on the level. In level 2 the wind will start to blow, and in level 3 it will start to rain. This is meant to introduce extra difficulties to the game over time. The concrete sound objects are defined in space and randomized in their movement, arrangement of sound and frequency of playback. The arrangement of the characters all follow the same principle. First, there has to be a bang, which gets sent from a randomizing sub-algorithm. The main part is a character-specific subpatch, in which the character arrangement, the visualization of the movement and the underlying volume control, the motion detection and the distribution of the points are defined. Finally, the sound is encoded into the ambisonics domain, in which it is mixed and the motion is defined. This is followed by the decoding subpatch. All sound processing into, during and out of the ambisonics domain is realized with the IEM plugin suite, a free and open source audio plugin suite consisting of a vast variety of ambisonics plugins. Alright, thanks for watching, and for more information follow the links in the description and check out my website. Thank you and peace out.